Hello everyone, this is your Kalpana here. In this video, we are going to see two problems from Laplace transforms using linearity property. So let's get going. I'll begin with the first one. Find Laplace transform of sine 2t into cos 3t. So here we are having sine 2t into sine 3t, right, which is of sine A cos B form, say. Okay, so now we need a formula which is involving sine A and cos B. So what I'll do is I'll use sine A plus B formula, which is sine A cos B plus cos A sine B, and sine A minus B formula, which is sine A cos B minus cos A sine B. Now I'll add these two, then cos A sine B minus cos A sine B gets cancelled and you'll get sine A plus B plus sine A minus B equal to sine A cos B plus sine A cos B. Which gives us sine A plus B plus sine A minus B equal to sine A plus B plus sine A cos B plus sine A cos B gives 2 sine A cos B, right? Now bring this 2 to LHS, we'll get 1 by 2 into sine A plus B plus sine A minus B equal to sine A cos B, right? From this we got sine A cos B equal to 1 by 2 into sine of A plus B plus sine of A minus B, right? So now we can apply this formula here. Since sine A cos B equal to 1 by 2 into sine of A plus B plus sine of A minus B, right? Now for A equal to 2t and B equal to 3t, we'll get sine 2t into cos 3t. For A equal to 2t and B equal to 3t, we'll get sine 2t cos 3t equal to 1 by 2 of sine 2t plus 3t plus sine 2t minus 3t. This gives us 1 by 2 into sine 2t plus 3t is 5t plus sine 2t minus 3t is minus t. Since we know that sine of minus theta is minus sine theta, right, then sine minus t becomes minus sine t. So we'll get minus sine t, right? Therefore, sine 2t into cos 3t is 1 by 2 of sine 5t minus sine t. Okay, or we can write this as 1 by 2 into sine 5t minus 1 by 2 sine t. You can use either of these two, or 1 by 2 sine 5t minus 1 by 2 sine t. I'll show you in both the cases. If if sine 2t into sine 3t is replaced by 1 by 2 of the first one, sine 5t minus sine t, we'll just take this outside and write 1 by 2 into L of sine 5t minus sine t. Okay, now we'll just apply the linearity property, sine of first function, L of first function minus L of second function, because we have already taken the constant outside. Okay, here C1 equal to C2, right? C1 equal to C2. If you multiply, listen, if you multiply 1 by 2 to these two terms, we'll get 1 by 2 sine 5t minus 1 by 2 sine t, right? Here C1 is 1 by 2. Just compare this with L of C1 f of t plus or minus C2 g of t. Then C1 equal to 1 by 2 and C2 equal to 1 by 2. Okay, we have the same constants. And here we can apply the linearity property, half into L of sine 5t minus half into L of sine t. Okay, here also you are getting the same thing, L of sine 5t minus L of sine t, right, is equals to 1 by 2 into L of sine 5t minus 1 by 2 into L of sine 5t. You will get the same thing. Okay, nothing to worry. Just go with the Laplace transform formula now. We have L of sine at equal to a by s square plus a square, right? Now compare sine 5t with sine 80, then for a equal to 5, and compare sine t with sine 80, then for a equal to 1, we'll get 5 by s square plus 5 square minus 1 by s square plus 1 square, which gives us 1 by 2 of 5 by s square plus 25 minus 1 by s square plus 1. Okay, here also you will get the same thing. Just compare sine 5t with sine 80, you will get 5 by s square plus 5 square minus 1 by 2 equal to, compare sine t with sine 80, then for a equal to 1, you'll get 1 by s square plus 1 square, which gives us 1 by 2 into 5 by s square plus 25 minus 1 by 2 into 1 by s square plus 1. Okay, now if you take 1 by 2 common from these two terms, you'll get 1 by 2 of 5 by s square plus 25 minus 1 by s square plus 1. You'll get the same thing. Okay, it's not necessary to take 1 by 2 common from these two terms, or it is not necessary to multiply 1 by 2 to these two terms to get this. Okay, fine. Now you got the same thing, right? Now I'll pick this and I'll solve the problem. This is equals to 1 by 2 into, now take the LCM of s square plus 25 into s square plus 1, you'll get s square plus 25 into s square plus 1, in the numerator 5 into s square plus 1 minus 1 into s square plus 25, right? This gives us 1 by 2 into 5 s square plus 5 minus s square minus into plus minus 25 by s square plus 25 into s square plus 1, right? This gives us 5s square minus s square is 4s square plus 5 minus 25 is minus 20 by s square plus 25 into s square plus 1. Now take 4 common from these two terms, then we'll get 1 by 2 into 4 times s square minus 4 5 is 20 by s square plus 25 into s square plus 1, right? 2 ones are 2 twos are, this gives us 2 times s square minus 5 by s square plus 25 into s square plus 1, which completes the problem. Now coming to the second one. Find Laplace transform of sine AT sine BT. So here you are having sine AT sine BT, right, which is of the form say sine A sine B. Now we need to find the formula which involves sine A and sine B. So I'll consider cos A plus B and cos A minus B. We have cos A plus B equals to cos A cos B minus sine A sine B, right? And cos A minus B is cos A cos B plus sine A sine B. If you add these two terms gets cancelled because we have minus sine A sine B plus sine A sine B, right? So what we have to do is we have to subtract the second formula from the first formula. Then cos A cos B minus cos A cos B gets cancelled and you'll get cos A plus B minus cos of A minus B equal to minus sine A sine B minus sine A sine B, right? Which gives us cos A plus B minus cos A minus B equal to minus sine A sine B minus sine A sine B gives minus 2 sine A sine B, right? Now multiply both sides of the equation with minus so that this minus will disappear. Okay, we are going to multiply both sides of this equation with minus now. Okay, into minus, then we'll get minus cos A plus B minus into minus plus cos A minus B equal to minus into minus plus 2 sine A sine B, right? Now bring this 2 to LHS, we'll get 1 by 2 into, I'll write these two terms as, first I'll consider the term which involves plus sign, so I'll get cos A minus B. Now I'll write the term involving minus sign, so I'll get minus cos of A plus B equal to sine A sine B. So you got the formula involving sine A sine B. Sine A sine B equal to one by 2 of cos A minus B minus cos A plus B. Okay, now we got sine A sine B equal to cos of A minus B minus cos of A plus B. See, if you know the formula of sine A sine B, then you can directly use this formula, or you may need to go with this procedure, right? It is easy. So it is easy to remember these two formula, right? Fine. Now coming to the problem. Now for A equal to AT and B equal to BT, just compare these two. Then for A equal to AT and B equal to BT, we'll get sine AT sine BT equal to 1 by 2 of cos of AT minus BT minus cos of AT plus BT, right? This gives us 1 by 2 of, take t common from these two terms, we'll get cos of A minus B into t minus cos of A plus B into t, right? Or we can write this as 1 by 2 into cos of A minus B into t minus 1 by 2 into cos of a plus b into t, right? Therefore, sine at into sine bt equal to 1 by 2 into cos of a minus b into t minus 1 by 2 cos of a plus b into t. Now, I'll replace sine at sine bt with this. Then I'll get 1 by 2 cos of a minus b into t minus 1 by 2 into cos a plus b into t. See, L of c1 into function of t minus c2 into function of t we are having, right? So now compare this with the linearity property formula. Then you'll get constant into L of function of t minus constant into L of another function of t, right? Since we know that L of cos at equal to s by s square plus a square, now we are going to apply this formula. Then the above expression becomes L of cos a minus b into t. Then for a equal to a minus b, we'll have s by s square plus constant a minus b whole square, a minus b whole square minus 1 by 2 into compare cos a plus b into t with cos at. Then for a equal to a plus b, just replace a by a plus b. Now we'll get s square plus a plus b whole square. Okay, now let's take 1 by 2 and s common from these two terms. Then we'll get s by 2 into 1 by s square plus a minus b whole square minus 1 by s square plus a plus b whole square. Now take the LCM of these two terms. We'll get s by 2 into here s square plus a minus b whole square into s square plus a plus b whole square is a LCM, and in the numerator we'll get 1 into s square plus a plus b whole square gives s square plus a plus b whole square minus of 1 into s square plus a minus b whole square gives us s square plus a minus b whole square, right? This gives us s by 2 into s square plus a plus b whole square minus s square minus into plus minus a minus b whole square by s square plus a minus b whole square into s square plus a plus b whole square, right? This gives us s by 2 into here plus s square minus s square gets cancelled. Now expand a plus b whole square and a minus b whole square will get a square plus b square plus 2ab into minus of a minus b whole square expansion is a square plus b square minus 2ab by s square plus a minus b whole square into s square plus a plus b whole square, right? This gives us s by 2 into a square plus b square plus 2ab minus s square minus into plus minus b square minus into minus plus 2ab by s square plus a minus b whole square into s square plus a plus b whole square. Here plus a square minus a square gets cancelled, plus b square minus b square gets cancelled, and this gives us s by 2 into 2ab plus 2ab is 4ab by s square plus a minus b whole square into s square plus a plus b whole square. Right? 2 ones are 2 twos are. This gives us 2abs by the denominator is equals to 2abs. 2ab into s gives us 2ab, so you'll get 2abs in the numerator, and in the denominator you'll get s square plus a minus b whole square into s square plus a plus b whole square. Okay, which completes the problem. So we have seen some problems from Laplace transforms in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.